Hello friends, today we are going to study LeftJoin in SQL, and that is a very important join. Every join in SQL is very important because we have to understand the mapping concept behind that, because SQL is about joins to fetch this data, to fetch that data, to combine two tables based on a particular condition. Every time we use that kind of a join, whether it is self join, left join, right join, outer join, so those all joins are very important. So the joins are important, but the main concept behind joins are like mapping, that what kind of a mapping is being used, from which table to which table mapping is used, what are we going to do with the remaining data or the remaining elements of the both the tables which are not getting mapped with any of the elements of the next table. So this is the main concept wherein like we need to understand what mapping is. So let us start. That is left join. Okay, left join in SQL. Okay, so I am creating two tables. Suppose I am creating two tables, tab 1 and this is tab 2. Okay, so this is 1, this is 1, this is 2, this is 3. Here I'm taking 4, 5, 1, 2. So this is the result set. Suppose, okay, this table has 4 elements, this table also has this table has 4 elements, this table also has 4 elements, and you can take it like it's not mandatory to have equal elements in both the table. They can have different number of elements in both the tables. That's not an issue. We just need to understand what kind of mapping we are going to do. So this is the result set of the left join. Okay, so one element you will be picking up from table 1 and you will map it with every element in the table 2, and if they are matching, then that will be accommodating a place in the result table. That's all. That is the simple scenario that you'll have to understand. So let's go on, move on. So I'm taking the first element of table 1, and you will say like first element I'm taking, okay, first element I'm taking from the table 1 and I'll map it with the first element of the table 2. Okay, so is that equal? No. So is 5 is equal? No. 1 is equal? Yes. So that will take a place in the result table. Again, I am taking the last element and first element. So I am mapping. No, they are not equal. Now they are taking the second element. Now you will tell that first and second element in the table 1 are same. So it's not needed for one to do this, second one to do the same operation. No, it's required because they all are separate entities. For the if they are in the same table, so they are separate entities, so that needs to be performed for the second element of the table 1. It's not this is 1, this is 1, we know, but the table knows that this is a different element and this is a different element. So this has to be performed, the same criteria, the same operation has to be performed from the same one again for the table 1. So I'm taking that, and the same way I'm performing again 1 I'll get, because 1 mapping with 4, no, to 5, no, 1, no, 2, 1 is similar, so it is coming. Now 2, the same way, only 1 is mapping, getting mapped equals to 2. 3, I am not getting any of the elements that is equal to 3 in the second table, so that will not come in this one. Okay, so this is the result table. Now the mapping we have done, equal common part in both the tables, common elements in both the tables we are getting, but there is one more logic in left join, that is if there is any element which is not getting mapped with any of the elements in the table 2 or not equal to any of the elements in the table 2, then that should even come and get a place in the result table. So 1 is coming, 2 is coming, but 3 is not coming. So this 3 also needs a place in the result table. So this is the complete result table of the left join. So simply, if you understand, left join equals to common elements plus remaining elements of left table. So common elements of both the tables and the remaining elements which are not common in both the tables are not getting mapped with any of the elements in the table 2, that will be coming under this, and so that will be the entire result. So now we'll ask that there is a question, there should be a question that what is left table and what is, how will designate that or how will understand that. So here you understand that the mapping is going to happen in this way. Mapping, we didn't took one element from this and then we are mapping with every element of this. We took one element from this table and then mapped with every element of this table. So that means this is the left table and this is the right table. So mapping was from this to this. Mapping was not from this to this. Mapping was from this to this. So that means this is the left table and this is the right table. You understand that? This much is clear. Now one more scenario we are going to take. Suppose we have one table, that is, this is table 1. Okay, here 1, 2 and one value is null. Here also table 2. This is left join, keep in mind. Okay, this is 0, 1, 3, 2, null. Now we have to do the mapping and find out the result set from these two tables. So the result set will be C. In the previous video of mine, I showed that null are different objects. They are always different objects, whether two nulls are present in the same table or two nulls are present in the two different tables. They are always different elements. They are always different objects. They point to the different objects. So they can never be mapped or they can never be equal to each other. So that is the simple concept you should keep in mind. But they are an element in the table 1. They are a very respected element in table 1, though they are different. If I am suppose adding one more null here, if I am adding one more null here, if I have added this null here, two nulls are there. They are different objects. They are not same, and these two are also not same, and these two are also not same. So none of the nulls are same objects. They are different objects. Okay, so suppose I have started mapping from this to this. That means this is the left table and this is the right table. This will have to keep in mind. Okay, this is the left table and this is the right table. This will have to keep in mind. So I am taking one element from table 1, mapping with all the elements of the table 2 one by one mapping you will do. I am getting only one element is equal to this, so it will be 1. Next element I'll take from table 1 and I'll keep on mapping with every element of the table 2. That will be only one element is equal, so that will come. I'm finding the left join. That you will have to keep in mind. Left join, and this is the mapping direction. That is from this table to this table the mapping will be done. So this is 1, this is 2. Now I am taking this null. Do I need, after seeing my yesterday's video, do you need to map this null with any of the elements of this? Because they will never map and they are never equal. So they are different. Now this null, are you, I mean, if means, are you like going to map up this null with any of the elements of this? Because we know that none of the nulls are equal. They point to the different objects, so they are always different. So there is no need of mapping. So this is the result that I have got after mapping both the tables, and these are the two elements in the result set which are common in both the tables, table 1 and table 2. But there are yet few elements left in the table 1. They are different objects, but they are elements of table 1. So every element of left table should be present. You understand? Every element of table 1 should be present. If they are matching, that will be present first, and then non-matching elements should be present. So first null is coming, this null, and then next null is coming here. So this is the final result set of the left join. This you will have to understand. This is the final result set of the left join. See, very clearly you understand. So this is the final result set of the left join. Now through Venn diagram, suppose if I am trying to make you understand Venn diagram, how you will do? Suppose this is table 1, this is table 2. Okay, so this is one table and this is one table. Suppose this is A, this is B. So according to you, what should be the left join set? So the first thing is that common part. I said common part. Now if you will see in this, common part is coming. 1 and 2 are the common elements in both the tables, so they are coming. So this is the common part in both the tables, so that is coming. Now these two nulls are not common in both the tables. These two nulls are, means we are not mapping these two nulls. So this null and this null are not common. In the same way, here also in this table, this this result set if we count for, then one was common in both the tables, this one was common in both the tables, 2 was common in both the tables, but 3 was not common in both the tables. So we understand that in this also, this is the common part and this is the remaining A, this is the left table, A is the left table, so this will also be a part. So this entire shaded region will be the part of the result set of the left join of these two tables if performed on. Okay, so if you write, please correct me if I'm wrong, A intersection B, this part, okay, and union A minus this A minus A intersection B. I think this will be the result set of if left join if performed and on the Venn diagram if you try to understand through this. So this was all about from my from left join in SQL, and I think that you all must have understood in a very better and clear and with a clear way. So if there's any problem, please try to reach out to me through comments, and if I know the answer, I'll definitely put on in the comment back. Because I want everybody to grow. Like, I mean, SQL is a very important thing these days, and these joins are very important to understand. Mapping is very important. Keep learning, keep enjoying. Thank you.